A bucket containing water is tied to one end of a rope 2.545 meter long and rotated about the other end in a vertical circle. Find the minimum velocity at the highest and lowest point in order that the water in the bucket may not spill. So, see here, the bucket is rotated in this form. This is the lowermost point, this is the uppermost point. You know it, if the water is not going to spill, it means at this point minimum velocity should be under root of Rg, and at this point it should be under root of 5 Rg. You have got the formula at the highest point this and lowest point this. So, if you are putting Vh, it is for the highest point under root of Rg. You have got under root of, this is 2.45 into 9.8 meter per second, and that will be around here 4.9 meter per second approximately. Now, at the lowermost point also Vl is equal to under root of 5 Rg, that is 5 into 2.45 into 9.8, and when you solve it you will be getting 10.78 meter per second. So, this is the minimum velocity at the lowermost point, this is the minimum velocity at the highest point. Now, see, a balloon mass m is descending down with the acceleration a, that is less than g. What mass m of its contents must be removed so that it starts moving up with an acceleration a. Suppose you have taken, this is a balloon here, its mass is m, so weight is acting mg, and suppose the retarding force is acting F is upward. F is the force here. Now, this is descending down, coming down with an acceleration a. So, we can write the equation mg minus F is equal to m into a. Newton's second law of motion we have used. Now, if you take another example here, another case, suppose you have removed mass m, small m content you have removed. So, now remaining mass is m minus m. So, weight is acting m minus m into g, force is that is upward only F, and now it has started going up with the same acceleration a. So, you can write here F minus m into g is equal to m minus m into a. This is second equation. So, now this is the first and this is the second. Using these two equations, you can get the value of small m if you solve it, and you will be getting m is equal to, that is twice of m a upon g plus a. So, if you solve this and this equation, you will be getting the value of mass m, but in this equation we have kept constant, that is a retarding force.